Hydrates are compounds which trap water molecules in their crystalline structures. Hydrates are going to be written with the correct ionic formula followed by a dot, that's not a multiplication symbol, and then some number of water molecules. So right here we have CuSO4, which is copper 2 sulfate, and then we have 5 water molecules attached to every one copper 2 sulfate. That's the formula for our hydrate. So to write the name for this, I would write the name for the ionic substance, which is copper 2 sulfate. And then you're going to use your naming prefixes mono, di, tri, penta, or mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca to indicate how many waters you have present. And then you have the word hydrate for water. So the previous one was copper 2 sulfate pentahydrate. So go ahead and practice naming these two hydrates. Pause the video and restart when you think you have your answer. For the first one, you should have got cobalt 2 chloride, because chlorine's a negative one and we have 2 of them, which makes cobalt have to have a positive 2 charge. We have 6 waters, which the prefix for 6, if you recall, is hexa, and they all are going to end in hydrate, so hexahydrate. If you haven't got the other one, go ahead and pause it and get your second one. You should have gotten magnesium chloride. We don't need Roman numerals because magnesium's in group 2A. And then 3 waters is trihydrate. To find our molar mass, first you're going to have to write your formula. So go ahead and pause the video and write your formula for barium chlorate hexahydrate. Restart when you have that. Your formula for barium chlorate should have been Ba, ClO3, 2, and 6 H2Os. So again, you should need parentheses and around chlorate and a 2. To find our molar mass, we're going to do exactly like what we did when we previously found molar mass. We find our element's mass on the periodic table. Barium's 137.33, chlorine's 35.45, and we have 2 of the chlorines. And oxygen is 16.00, and we have 6 oxygens. Water, you can break it up, but it's usually easier to just remember the mass of water because we use it so often, and that's 18.02. We have 6 waters, so 18.02 times 6 is our mass due to the 6 waters. Add all your products up, and you should get 412.35 grams per mole. Go ahead and pause the video and try this one on your own. First thing you should have done was write your formula. Sodium sulfate's Na2SO4 with 4 water molecules. Giving us B191.14. Sodium was 22.99 times 2, sulfur was 32.07, and oxygen was 16.00 times 4. We had 4 waters at 18.02 times 4. And then we add all these up. Again, that is not a multiplication sign between sodium sulfate and water. It's just to separate it. We can also solve empirical hydrate problems, but before we can do that, we need to know 2 things. The mass of the anhydrous compound, which is the dry dehydrated part of it, and the mass of the water that's trapped within. The mass of the water is what's going to be driven off when you heat it. These are the steps that we'll be solving or going through when we solve this problem. Then the steps are located in your notes. So a chemist heats 300 gram sample of a hydrated iron 3 nitrate until all the water has been given off. The anhydrous is found to weigh 179.7 grams. They want to know the correct name of the hydrate. So iron 3 nitrate is the beginning part, and we know we have some amount of water. We're trying to find what N is. It could be 1, 2, 3, we don't know. The entire thing is the hydrate. Iron 3 nitrate is the anhydrous compound, because it's what would be left after the water was gone away. They gave us the mass of the anhydrous. We need to know the mass of the anhydrous and the water to solve the problem. So if we look back at the problem, it says that the entire hydrate was 300 grams. I know the mass of my anhydrous was 179.7, so I just subtract 179.7 from 300 to give me the mass of water. Because the anhydrous and water should always add up to the mass of the entire hydrate. That gives me 120.3 grams. Now, this is an exact problem that we did in the previous video, finding the empirical. Except instead of dividing by just one mass, we're going to divide by the mass of the entire compound. So the molar mass of iron 3 nitrate is 241.88, and the molar mass of water is 18.02. So you divide by the molar mass, and then just as before, we're going to divide by the smallest, which is 0.7429. And we get 1 and 9. Unlike the other empirical problems, you will not multiply at the end. So you just divide by molar mass, divide by smallest, and then round to the nearest whole number. And that's our correct formula for our hydrate. The correct name would have been iron 3 nitrate non-hydrate. Go ahead and pause the video and figure out your formula for this hydrate. So we have iron 2 sulfide, and we have water. Again, you have to know those two things before you can find the empirical. We know the percent of water, so that's how many grams we have. And assuming we have 100 grams of this substance, we can find our mass of iron 2 sulfide, which should be 55.74. Now divide by molar mass. Iron 2 sulfide's molar mass is 87.92, while water's 18.02. Now we're going to divide by smallest, which is 0.6340. And we get 1 and 3.87. But again, you will not multiply, so that rounds to 4. You may want to make note that you can't multiply in hydrate problems. So our formula is FeS and then 4H2O, or iron 2 sulfide tetrahydrate. Go ahead and read this problem and try to solve it on your own. Restart when you have your answer. First, we write our anhydrous formula down and then water. They told us the amount of water that's released is 180.35 grams, so that goes down here. And I know the mass of my entire hydrate, so 500 minus 180.35 grams gives you the mass of copper 2 sulfate, which is 319.65. Divide by molar mass. Divide by smallest, which is 2. And so our formula is CuSO4 with 5 H2Os, or copper 2 sulfate pentahydrate. And that concludes this video.